I'm Anil Kumar, and here we have 10 questions on vectors in R2 equation of lines. We'll begin with question number 1, which is write equation of line through point A, 1, 4 with direction vector 3, minus 2. You can always pause the video, answer the questions as we move along. So what we're given here is point A, which is 1, 4. And we are also given direction vector m as 3, minus 2. You can write equation in any form you want. Let's begin with the vector equation. The vector equation could be written as the point. We say the position vector 1, 4 plus t, the parameter, times the direction, which is 3, minus 2, where t belongs to real numbers, right? You could also write this in symmetric form, saying x is equals to 1 plus 3t and y is equals to 4 minus 2t, right? So that becomes the parametric form. In symmetric form, you could write this as x minus x coordinate divided by the direction equals to y minus 4 divided by minus 2, right? So in different forms, you can write it. You can actually also write it in Cartesian by multiplying them and rearranging. Let me show that also to you. So we could do this as, let me do it, minus 2 times x minus 1 equals to 3 times y minus 4. So when you cross multiply, you get this. Then you get 2x plus 2 equals to 3y minus 12. Rearrange them, so we get 3y plus 2x. Bringing this on the other side gives you minus 14 equals to 0. So what we saw in the very first video is how we can write an equation in different forms. This is the vector form. That is called the parametric form. This is symmetric. And then finally we got scalar or Cartesian form. Correct? So you've also seen how we can rearrange one equation and write in different forms. Correct? Let's move on now to question number 2. And here we'll discuss how to write equation of line passing through 2 points. So we are given 2 points A and B. So we are given A as 2, 5. And we're given B as 5, minus 1. So we can find the direction AB. So direction AB will be what? Direction AB will be 5 minus, let me write 5 minus 2, minus 1 minus 5, correct? Which should be 5 minus 2 is minus 3, minus 1 minus 5 is minus 6. So that becomes the direction AB. Now you could do like this, or you could also take minus 3 common, right? If I take minus 3 common, I could write this as 1, 2. So I could also write this as direction 1, 2. This is very important step. So we can say that the direction is basically 1, 2. Is it okay? And we can write vector equation as xy equals to any point you can choose, let's say 2, 5, plus t times the direction, which is 1, 2, correct? T belongs to real numbers. It could be negative. It could be negative 3, for example, to get to the next point. So by giving different values of t, you can get all other values. I hope you find it interesting. Now, as an exercise, you could convert it in different forms, right? So that is an exercise for you. So that is an exercise for you. You should do that on your own, just as we did in question 1. Is it okay? So let's move on to the next question, which is question number 3 here. It says, draw a closed triangle that represents vector xy equals to 1 minus 2 plus t, 3, 4. So let me make a bigger sketch here. We have some negative value also, so I'll leave some space here, kind of like this, right? So that is our xy coordinate. So we're given a point here which is 1, minus 2. So let's say this is 1 and then minus 2 means 1, 2 down, right? So that is minus 2. Is it okay? So I'm saying this is minus 2 and this is 1 for us. So we got 1 point. Now the direction here is what? So let's write down. So we have a point, let's say A, which is whose coordinates are 1, minus 2. Is it okay? Okay. And the direction we are interested in is 3, 4. So the position vector OA will be what? OA will be 1, minus 2. Is it okay? That gives you position vector. So I could draw this as from O, an arrow like this. Do you see that? So this becomes my position vector OA. Now from here we have to move in this direction, 3, 4. So this is 1 for us. Let's say this is 1, 2, 3 units, right? 3 units. 4 means 2 and 2, right? So kind of. So that becomes my direction. So that's the second point for me, correct? So we're basically moving along this direction, and therefore I can draw my line connecting these 2 points, correct? So I can have a line which is kind of like this. Do you see that? Now we could have gone minus 3, minus 4, get a point here. We could go 2 times. So we could get n number of points here. Remember, in all these equations, t belongs to real numbers, correct? So what you notice here is that the second point here could be represented as B. So we could call this as a point B. And AB is actually, that direction is t times 3, 4, right? In our case, t was 1. T equals to 1. To get the point B, so we have coordinates of B as, we can just add them up. We get 4 and 2. Do you see that? So we get this point as 4 and 2. And that point was 1, minus 2. Correct? So when we are saying that draw a closed triangle that represents vector xy equals to this, then that is the closed triangle. That is the closed triangle. Is it okay? So from here we can write OB equals to OA, position vector OA, sorry, plus whatever this is, which is 1 in our case, 3, 4, right? In general, we'll write this as t because this could be any point here. Do you see that? So that is what? So this is t times 3, 4. So that gives you the closed triangle which we are talking about. So I hope this concept is absolutely clear, right? So let's move on. Here is question number 4 for us. Question number 4. Write equation of vertical and horizontal lines. So we are given different conditions, 2 of them. So let's consider, let me make a small sketch here. We are given a line which passes to 2, minus 5 and is parallel to x-axis. 2, minus 5, let's say somewhere here, parallel to x-axis, kind of like this. So we want equation of this line. Parallel to x-axis means what? Means that the direction is, we are only moving along x-axis, that is 1, not along y, 1, 0. And therefore, the equation could be, we could write this equation as, in vector form, as xy equals to, starting with the position vector 2, minus 5, move along 1, 0. Do you see that? So that could be your equation, correct? Now it's sometimes difficult to write this equation in symmetric form, right? So in symmetric form, how are you going to write? Well, you could do x minus. So you're moving only along the x direction. So you could write x minus the x value divided by 1. Okay, so that means x minus 2. But y, you cannot divide by 0. So you'll write y as equals to minus 5. Do you see? So that becomes the equation in symmetric form. Very important to understand. Let's look into the next example here. It says passes through the point minus 1, 3 perpendicular to x-axis. So minus 1, 3 may be a point somewhere there Perpendicular means the line is vertical. Do you see that? So that is the line which we are talking about in this case. Correct? Now here we could again write the equations as we did earlier as xy in vector form. We prefer to write minus 1, 3 if a choice is given, right? Plus t times perpendicular, that means you are moving only along y, not along x. X value is constant, correct? And therefore it is 0, 1. That's how you will write. Perfect. So that becomes the equation of the line in that form, right? So that is how we should be doing it. So I hope that concept is clear. Now let's move on to question number 5. It says, write equation of line in Cartesian form for xy equals to minus 2, 3 plus t, 1, 2. Now to write equation in Cartesian form, we can adopt different methods. I will show you 2 different methods in this particular example. One is, when we are given this point, we are given the direction which is 1, 2, and we are given a point which is minus 2, 3, right? Now, since this direction is given, we can say normal is what? Normal is flip it and change one of the signs. We can say 2 minus 1, right? And we can still consider the same point which is minus 2, 3. So in Cartesian form, if I know the normal, the equation will be ax plus by plus c equals to 0. So a is 2, so we get 2x minus y plus c equals to 0. Substituting this point for x and y, we get 2 times minus 2 minus 3 plus c equals to 0, and that is minus 4 minus 3 plus c equals to 0, or c equals to minus becomes plus when you take this side, 7. And therefore the equation is 2x minus y plus 7 equals to 0. Do you see that? So that is one way of doing this question. The other way is, from here you could write the symmetric form, which is x minus x value, which is minus 2, divided by 1 equals to y minus y value, which is 3, divided by 2. Now you cross multiply. So this could be written as x plus 2 equals to y minus 3 over 2. When you cross multiply, you get 2 times x plus 2 equals to y minus 3, 2x plus 4 equals to y minus 3, or 2x minus y plus 4 plus 3 equals to 0, 2x minus y plus 7 equals to 0. So you get the same answer, right? So that is how you should be doing it. To understand the concepts, look into part 1 of my video, right? Here is question number 6. We are already midway through our set of 10 questions. Question number 6 is, write equation of line perpendicular to the line 2x minus 3y plus 6 equals to 0 that pass through point P, 1, 2. You can always pause the video, answer the question, and then look into my suggestions. Now when I say that it is perpendicular to the given line, this line is given to us in which form? Cartesian form, right? Plus 6 equals to 0. Now from here you can find the normal to the line. Normal is 2 minus 3. Normal is 2 minus 3. If that is the normal, then the direction vector will be flip it and change one of the sign. So we made minus 3 as plus. Perfect. Now that becomes the direction. Point is given as 1 and 2. So we could write this equation in vector form as position vector 1, 2 plus t times 3, 2. Okay. So that is how you could actually easily write this equation from the given conditions. So I hope you appreciate this particular method. So when you are given equation in the Cartesian form, then, so let me rewrite here. If the equation is ax plus by plus c equals to 0, then the normal is ab, right? And the direction is, you could flip this and change one of the signs. that helps to solve such questions, correct? Question number 7. Determine if each given point is on this particular line. We are given 2 points. So let's rewrite this equation now. I'll prefer to write this equation in parametric form. X equals to 3 minus 2t and y equals to 1 plus 5t. So let's check the point A, which is minus 1, 11. That really means x value is minus 1, y value is 11. So let us work with x value of minus 1 here. So if I substitute x as minus 1, let's find t. So for x equals to minus 1, I'm substituting minus 1 equals to 3 minus 2t, or we can say 2t equals to 3 plus 1, which is 4, or t equals to 4 over 2, which is 2. Now if t is 2, what is y? We can say y equals to 1 plus 5 times 2, since t is 2. And 5 times 2 is 10, and that gives us 11. So therefore, we get the same coordinates, which are minus 1, 11. So we get the coordinates minus 1, 11, and therefore, this is on the point. This point is on the line. Is it okay? So that is how you could verify whether a given point is on the line or not, correct? Now let's check the second point, which is B, 5 and 6. Now to check 5 and 6, I'll again substitute 5 for x, right? So we'll write here 5 equals to 3 minus 2t. Now we can write 2t equals to 3 minus 5, which is minus 2, or t equals to minus 1. If I substitute minus 1 for t, what do I get for y? I get y equals to 1 plus 5 times minus 1, which is 1 minus 5, and that is minus 4. So the point actually is at x equals to 5, the y value is minus 4, so not 6. So this point B is not on the line. Is it okay? So that is how you could verify. So let's say we check this part like this. Is it okay? So that is how you can verify whether a given point is on the line or not. Here is question number 8, which says write equation of line perpendicular to the given line, right? And that also passes through a given point. So let's write down or rewrite the equation. X is given to us as 2 minus 3t. Y is given to us as 1 plus 2t. Now from this equation, which is a parametric equation, what is the direction? So M, the direction is minus 3, 2, correct? That is the direction. Now it says write equation of line perpendicular. So perpendicular line will be what? Perpendicular means the direction should be, let's say direction M2 should be how much? We have to flip this, right? And change one of the signs. So 2, 3 becomes the direction. Since we know perpendicular direction is this and it goes through the point P, which is 1, 2, we can now write the equation as xy, okay, xy equals 2. So the point is 1, 2, right? So position vector 1, 2 plus t times 2, 3. Is it okay? Where t belongs to real numbers. That is how you should be doing it. Or if you want it in this form, you can do that also. You can write x equals to the given point 1 and the direction is 2. So it becomes plus 2t, and y equals to 2 and direction is 3, right? So plus 3t. So that is in symmetric form. So likewise, you can easily answer this question. I hope that is correct. You can also write this in scalar form. Let that be an exercise for you. So rewrite the equation in scalar form. So I hope you are getting good practice of writing vector equations in R2 for a line. Question number 9 here is, given scalar equation x plus 2y minus 6 equals to 0, write vector, parametric and symmetric equation. Correct. So what we are given here is x plus 2y minus 6 equals to 0. So from here you can get information for normal. So normal is 1, 2, correct? The coefficients of x and y gives you normal to the line. Since the normal is 1, 2, the direction should be what? Direction should be, you flip it to 1 and change one of the signs. I prefer to change the y point. So that becomes the direction now, correct? These two, if you do dot product, you'll get 0. So we get this. Now we say given scalar equation of this, write vector, parametric and symmetric equations. Since we have our given direction, we can easily write any equation, right? So what we will do here is we'll find a point on this line and then write all those equations. So in this exercise, since I didn't take up anything for x-intercepts, let's find x-intercept. So I'll take that point as my point on the line. So x-intercept means y equals to 0. So if I have to calculate that, I'll put y equals to 0. I get x minus 6 equals to 0. That means x equals to 6. And so the x-intercept is 6, 0. So that becomes my point. So let me call this point as x. Okay. Since I have a point here, I'll write all the different equations. So first, vector equation. So the vector equation will be this point, which is 6, 0, position vector, plus t times the direction, which is 2 minus 1, where t belongs to real numbers, correct? You could use any lowercase s, t, p, q, whatever you want. Anyway, parametric will be, you can write x equals to 6 plus 2t, y equals to 0 minus, so minus t. Do you see that? So that becomes parametric. To write symmetric equation, let me write down on the right side. To write symmetric equation, since I am working with this point now, I can say x minus 6 over, the direction is 2. Right? Now, and the y value is 0. So I'll write this as y minus 0. That means y and over minus 1. Do you see that? So that becomes the symmetric equation, correct? So that is how you should be answering. So this is symmetric. That one is parametric. And here we have vector equation. I hope that's absolutely clear. Now last question here, question number 10. It says, write vector equation from the given symmetric equation, right? So the equation given to us is x minus 2 over 3 equals to 3 minus y over 2. This is kind of tricky part. So look carefully. You can actually try this question and then look into my solution, right? We need to rewrite this. Like this should be like minus y plus 3. I'm taking additional steps to make it absolutely clear. Over 3 equals to, we should always have this as positive. So I could write this as minus of y minus 3 over 2, or that is what I wanted to write. You could do direct y minus 3 divided by minus 2. Do you see that? Actually speaking, that is how this equation should have been written. Now you know that we are working on a point P which is 2, 3. And the direction is 3 minus 2. Do you see that? Once you know that, you can write the vector equation, which is 2, 3 plus t, 3 minus 2. Do you see that? Where t belongs to real numbers, right? So as an exercise, I'd like you to write this equation in all other forms. which you've learned in part A of my video. So with this, we conclude our practice questions on what we have learned in part 1. We'll have a quiz in part 3 to follow up. I hope it really helps. Feel free to write your comments and suggestions. Thank you for watching and all the best.